In this video, we'll be covering a couple more examples on logarithmic and exponential functions of different bases. Again, not natural bases. So, when looking at this first example right here, 7a, we have log base 3 of 4x minus 7. Now remember, again, if it helps, recall the derivative of the natural log function is 1 over x, 1 over anything. So the derivative of any other base is going to be 1 divided by whatever's inside there, 4x minus 7, times, again, we're always going to tack on some kind of extra piece, and since the log function forces us to divide, we're going to tack on the natural log of 3 into the denominator. Now, unfortunately, we're not entirely done with this problem, because remember, all we've taken the derivative of right now, in this piece right here, is this natural log of 3 base. The natural log of 3, if we've taken the derivative of that, we must look to the interior of that function. Now keep in mind the base 3 is not an interior piece of that function. It is attached to the log function. It is part of it. So the interior is just this 4x minus 7. And the derivative of 4x minus 7 is simply 4, which provides me with, if I simplify this ever so slightly, that. Okay? Just moving it up on top. If I look at this function over here, it is 6 to the power of 9x minus 4. Now again, let's recall, e to the x goes to e to the x. So the derivative of 6 to the anything is going to be 6 to that anything. And then don't forget we have an extra piece to tack on. It's the natural log of that base, 6. Okay, again, e to the x goes to e to the x, so 6 to the anything goes to 6 to the anything times the natural log of that. That is the derivative of 6 to the anything. Don't forget we have to apply the chain rule. The interior stuff is 9x minus 4. What is the derivative of 9x minus 4? 9. In this case, I'm going to be left with 9 times 6 9x minus 4 times natural log of 6. Now there's a number of different ways we can rewrite this, but I want to make an emphasis here that 9 times 6 to the power of something is not 9 times 6 together to the power of something. These two entities, and actually all three of these entities, must stay separate. The most you can do in terms of what looks like combinations is going to be 9 natural log of 6 times 6 9x minus 4. Okay, and again, this natural log is, this 6 is inside this natural log, so it cannot be combined with this 6 over here. This 6 is part of this exponential function, so it cannot be combined with anything over here. All of these three pieces, 9, natural log of 6, and 6 to the power of 9x minus 4, are all separate entities. And that is my g prime function. Lastly, let's look at 7c, where 7c is a much more complicated example. You have log with no base of 3 to the power of x minus 3 plus 6x squared. Now, when I say no base, I don't actually mean no base. Just recall that if I don't write a base, just like ln has a base of e, log with no base has log base 10. So these two things are actually equivalent. So now when I go to take my derivative, h prime of x is going to be equal to, well, remember, I'm taking the derivative of a log. The derivative of a natural log is 1 over whatever's inside. So I'm going to first start with that piece. The derivative of any log is 1 divided by the inside stuff. Don't forget that we have to multiply in the denominator by the natural log of the base, where the base in this case is 10. So that is the derivative of log base 10 of anything. Now don't forget to apply the chain rule to the interior. So what is the derivative of 3 to the power of x minus 3 plus 6x squared? Well, don't forget, when there's a plus or minus sign, we can separate into two separate pieces. So the derivative of 3 to the power of something is going to be, remember, 3 to that power times the natural log of the base. That takes care of 3 to the anything. Then the derivative of x minus 3, we just better make sure we check, is a 1. Okay, so that's not going to change the derivative of that thing at all. Then we look to plus the derivative of 6x, which is nothing more than 12x. Okay, now very carefully, if I can simplify anything, I'm going to go ahead and put this thing in parentheses, even though it's not necessary. I'm going to put this thing in parentheses, even though it's not terribly necessary. And I'm going to go ahead and try and simplify this stuff as much as possible, which by simplifying what I mean is this. I'm going to go ahead and write 3 to the x minus 3 times the natural log of 3 plus 12x, that is all on top, divided by 3, I wrote x twice here, this should be a 3. 3 to the power of x minus 3 plus 6x squared multiplied in parentheses by the natural log of 10. Again, that's as much simplification as we're willing to do on this type of example, but that right there is the derivative of that function. Again, we're just practicing the skill of how to take derivatives, making sure we know how to apply the chain rule, the product rule, the quotient rule where necessary.